So given that we've just done the integer programming example, how about trying one on your own? So here we have a scenario where we make two products, X and Y, using machines A and B. Each unit of X that is produced requires 50 minutes of processing time on machine A and 30 minutes of processing time on machine B. Each unit of Y that is produced requires 24 minutes of processing time on machine A and 33 minutes of processing time on machine B. At the start of the current week, there are 30 units of X and 90 units of Y in stock. Available processing time on machine A is forecast to be 40 hours and machine B is forecasted to be 35 hours. The demand for X in the current week is forecast to be 75 units and for Y is forecasted to be 95 units. We want to maximize the total amount of stock that we have. So take a moment and see if you can create the formulas that go with this, and then we'll go through them, and then you can see if you can create the code to create this using the example that we went through just a moment ago. All right, so what are we trying to do? We're trying to maximize the amount of units we have on hand. So that's X plus, we already have 30, plus Y plus the 90 we already have on hand. Now we need to look at our constraints. We are constrained by machine A, we are constrained by machine B, and we are constrained by our demand. So machine A is 50 minutes times X, and of course I can't see it here. And so in 24 minutes for Y, okay, and machine A only has so much time. We have that listed here somewhere. 50 minutes processing time on A, 30 on B, 24, 33. Available processing time for machine A is 40 hours. So that means that we can't use more than 40 hours, and here we have to convert that into minutes. Machine B, we have that it takes 30 minutes for X, it takes 33 minutes for Y, it must be less than or equal to, and here we have B has 35 hours available times 60. Okay. All right, then the other constraint is that we have to have enough to meet demand. So we have X plus 30 must be greater than or equal to 75. And Y plus however much we already have on hand, which is what, 90, must be greater than or equal to 95. Okay, so we have our constraints here. Notice some are less than, some are greater than. We want to maximize our total units. We would go in, and if you're doing this, you're going to add a couple lines of code here, and then you're going to repeat the process you did before. So we're going to copy here our model. We are going to maximize. We have variables. Here we have 2. X and Y, and they are integers. Okay, so we'll run our model, define our variables. Now we need to add in our maximization problem. So here was the code from before. We're going to change that code. So if we go back and look, we have X plus 30, Y plus 90. X plus 30, Y plus 90. Okay, put that into our system here. All right, now let's add some more lines of code. Here we're going to put in our constraints. So I'm just going to copy this code so we have it as a template. And we have machine A and B. We have inventory X and Y. So let's change those formulas. We have 50X plus 24Y. 50X plus 24y. Okay, and that is less than or equal to 40 times 60. 40 times 60 and defined. All right, our second scenario here, we have machine B, 30x plus 33y. 30x plus 33y is less than or equal to 35 times 60. Okay, and then the amount of inventory on hand, x plus 30 must be more than 75. All right, and here we have y plus 90. Let's try that again. Y plus 90 must be greater than or equal to 95. All right, let's put that into the system. And then the last piece here, we just copy word for word. Model solve. And have it output. And what that tells us is we need to make 45x and 6y. We can also graph all of our constraints because we only have two variables. So we're going to take the code here from that first video that you saw to manipulate that. Notice that these products go from basically 0 to 50. So I'm actually going to change this 0 to 50. And 50 times 50 is actually 2,500. And then I need to throw my formulas in. So here, paste that there. Copy this. Paste it here. Copy this one. Paste it here. And I got more constraints here, so I'm going to put and I'm going to put in parentheses, and I'm going to add the last one. Okay. All right. The rest of it we can leave, although we don't have chocolate chips. We have inventory X or product X and product Y. Okay, and let's run this. See if I screwed it up. Nothing inside there. All right. Range. Oh, see this little tiny gray right here? That is where the possible solutions reside. It's really hard to see. So you can't quite see here, but we have a line here, a line here, a line here that are constraining it. And so all of the possible solutions are just this tiny dot. And of course, we are trying to maximize, so we want to be the top of that tiny dot. And that's why we end up with our solution at 45 and 6. You can see here at about 45 and 6. So notice that because this one has more constraints than, say, the previous example, that gray space is a lot tinier in terms of our solution.